Welcome everyone. Another update, another monthly update from Jason Hill on the status of the build of the HX50. It's really a journey. We're enjoying this so much and people connecting literally from all over the world. I can see Argentina, California, I see Brazil, Houston, Mexico. So many people connecting. Another moment for us to get together and hear about the update. And Mischa, what is the program for today?
Awesome. We have a great program. Jason's going to do the usual update. It's going to take about 45 minutes from across the program, giving you all the latest updates of what's been happening this last month. And then we're going to move into our AMA session. AMA stands for Ask Me Anything. So we want you guys to post all of your questions, any questions that you guys have, post them there in the chat. And then we're going to be presenting those to Jason at the end. And we're going to take as long as we need to answer all of those questions. It's always a really fun time to be able to have the opportunity to ask the founder, Jason Hill, any question that you'd like to have. So that's going to be at the end. So start putting your questions in there right now. And without further ado, we're going to pass our time over to Jason. So Dr. Jason Hill, the founder of Hill Helicopters, thanks for being here. And we look forward to another update.
Thanks, Mischa. Thanks, Ruben. And welcome, ladies and gentlemen, to a increasingly busy DC1. Tonight we're going to give you an update from across the program, focusing on the airframe developments, engine, drivetrain, a little bit on digital cockpit, and then as we march towards production, all the work we're doing on the development of our 350,000 square foot facility and all of the specialist equipment that needs to go inside it to build this fantastic aircraft and engine. So let's start with the airframe. For those of you that have been following our progress over the last few months, particularly since just before Christmas, you'll have seen us develop absolutely everything that we need to do to build in-house patterns, in-house molds, and then our own in-house advanced infused carbon fiber fuselages. This is crucial to the success of HX50. It's the underpinning of our structural performance, of our crashworthiness, of our aerodynamics, and of a lot of other key attributes in the helicopter, not to mention, of course, the price point. Now, those that have been following closely will have seen that first we developed our very first airframe, which was just about the basics of infusion, the basics of fabric handling. Then we produced a second airframe, which was a refinement of that. In the third airframe, we've been on to optimize and perfect the infusion of the outer shell. And then with our fourth airframe that we're going to be talking about today, we then introduced the structural cores and all of the things that you need to turn that monolithic shell into a real aerostructure. So without further ado, let's go over and have a look at the first three of the airframes that we've developed over the course of the last few months. So airframe 1, which we've got here, was very much about the basics of infusion. Remember, what we're doing here at Hill is we're using infused composites. Now that's important because it means we get to take dry fabric and resin separately and then combine them within the mold. That allows us to make aerospace grade composites at the lowest possible price point. But it does mean that we've got an awful lot of process development to carry out before we can produce reliable, cost-effective and quick monolage structures. So airframe 1 was the very first attempt at doing all of that, and it was very much about what have you got to do to take dry fabric. It's like trying to stick your shirt to the ceiling. What have you got to do to get the carbon fiber to stick in all the parts of the mold, and then get a vacuum bag over it, and then be able to draw resin all the way around this completely circumferential void using just vacuum. And that's what this was really all about. Now, in the first instance, it worked okay. We nailed the ability to hold the fabric in the right place. We got a lot of the infusion strategy right, but it wasn't perfect, as you'd expect. It was the first time we'd done it. Details like this up here, where we're trying to get the carbon to flow smoothly over the joggle details that we need to create the flush exterior of the helicopter, proved quite difficult, and we've had to develop new and improved processes to be able to do that. The other thing that we did is we were able to take the transparent panels that cover the exterior of the aircraft, develop the trimming techniques to get these trimmed to shape, and have a look at the gap and flush and fit details of all of these components as they came out of the process, so that we can assess and understand just how much control we have to exert in these parts to get the thing to sit together as a quality product. We then went on, and this airframe will eventually be used as what we call a human factors mock-up. So that's just to make sure that we've got the right range of travel in the seats, in the flight controls, that everything falls conveniently to hand. It'll allow us to sanity check with our smallest and tallest customers that they can get in. Things like grab handles and all those other things that we need to do, we can verify with this one. So that's what this one's going on to do. If we now go over and have a look at Airframe 2, we can have a look at what the next step that we took in the journey to producing a high quality, cost-effective composite airframe was. So what you can see here is the second iteration of our airframe. Now, one of the most important points to realize here is that first airframe, it was the first time we did everything. It was the first time we cut the kits, it was the first time we used the tools, it was the first time we drew a vacuum, all the bagging technologies and everything else we had to develop to get it to work. We'd got those nailed down by the time we'd built this one. So this one was much, much quicker. Whereas that first fuselage we were working on for roughly a couple of months, this one was done in 2 to 3 weeks. So a lot of the processes within the organization had started to gel, and we were already able to produce these much quicker. Even though there's no automation at the moment, this is purely done as a prototyping exercise. So in this, we refined the way we did the infusion, we refined the way that we wired up and plumbed all of the vacuum lines and the resin injection ports. We changed some of the infusion parameters, we upped the temperatures. We did a vast number of things to make this one work better, and work better it did. Whereas fuselage 1, if we look back in here for a second, had got large dry patches in the roof where we hadn't successfully managed to get the resin everywhere. By the time we went to the second attempt on this one, the whole fuselage was wetted out properly. We looked at bootlaces and we looked at intensifiers and resolved a lot of the edge detail better. It wasn't perfect yet, there were still some things we can do, and there were still some things around the doors and a couple of other little areas where there was still scope for improvement. The other big thing that we did is the first set of structural foams that we had made. We used to fit out the structure, and this was really the first time that we got any real sense of what it's going to be like to be within HX50, the size of the pillars, the size of the structural members that protect you and provide your crash cell, and also it was the first time that we got a real sense of the stiffness of the airframe, because the outer shell that we produced in isolation, of course, has no stiffness, has no strength until it's got all of this stuff, and then the B surfaces on the inside as well. So this one came next. We then used this one to template all of the kit cutting that we need to do for the fibers that then produce the finished structure overall. So let's go over and have a look at Airframe 3, and we can see how we moved on as we went from the second iteration to the third. Now, Airframe 3 is by far and away the best one that we've made yet. So this is still an exercise in producing a perfect outer shell. So this is just the outer shell, the outer skin of the airframe. But as you can see now, with the improved bootlaces, with the improved intensifiers, all of the details that you need to create the recesses for the doors so that the doors fit flush with the fuselage and maintain that clean aerodynamic shape were captured perfectly. We also managed to get the infusion almost perfect. There was only a couple of tiny little dry spots up here, which were purely because we clamped down a little bit too hard on how we simplified the resin distribution and the infusion approach. So Fuselage 3 worked an absolute treat. It was much, much faster. We managed to produce this airframe in a little over a week. And by that point, even with no automation, you're already starting to get to the point where these infused composites using our methods, our patterns, our tools, our infusion strategies, almost to the point where they're a production process. So there's still more work to be done on this, but the very next step, of course, is to start building in the foams, put the B surfaces in, and make Airframe 4. And that is what we've been working on over the course of this month. So let's go back and have a look at some of the ingredients that have gone into building Airframe 4 over the course of the last 4 weeks or so. So one of the way that a composite structure works is all of the loads are carried by the skins, but something has to position the skins of the structure in the right place. To do that, we generally use trapped foam cores. And these are very lightweight structures. They carry very little of the load, but they just make sure that we can create the box sections and the other structural details that we need to produce high strength, high stiffness, high integrity aerostructures. All of these foam cores are manufactured in-house by us down at DC2 on our gantry mill. And so what we've been doing over the course of the last month is developing optimized machining strategies that enable us to produce these things as quickly as possibly, as accurately as possible, and with the least possible weight. So in the first instance, when we made the first set of cores that have gone into Airframe 4, it was very much about doing it quickly. But in doing that, we found that we were wasting vast amounts of machining time and also vast amounts of material. So over the course of the last month or so, we've been developing strategies to take these random shapes that form the beams and the floors from around this beautifully curved fuselage and nest those into single blocks of foam so that we can machine lots of parts in a single operation. And in doing that, we've dramatically reduced the wastage, we've dramatically reduced the time it takes to machine the foams, and we've also essentially improved the accuracy and the reliability of the whole process. Now, this is a process that we'll only really be using for prototyping. It's just too wasteful and too expensive to do this for production. So in parallel with this exercise, we've been developing with our foam suppliers a moldable solution, which allows us essentially to take the same foam chemistry, but take the raw ingredients for that and then reaction injection mold that into molds that are the form of the beams that we need, or the foam cores that we need to put inside the structure. That reduces the cost of producing exactly the same thing to exactly the same specification by about a factor of 100. And so this is a really, really important approach for, again, getting the cost of these aerostructures down to a level that general aviation can afford. So what we can do now is we'll just go over and have a look at some of the cores that we've been doing. Now, the things that we've been developing with these cores essentially are sorry, I'm on the wrong slide. So before I talk about that, I'll talk about trap foam structures themselves. So one of the things that you've got to do once you've got your cores is you've got to make sure that you've optimized the infusion strategy so you can physically get the resin over these convoluted shapes. In the shell infusions that you can see over there, we've essentially just got to run the resin through a single void. But the moment we have one path and then a foam core and a convoluted carbon path over the top, we have to make sure that not only can we get the resin over these features, and there are lots of ways that we can ensure that resin can track around them. We have to optimize all of those things, but of course the only thing that holds the foam core in place within a vacuum bag is the vacuum itself and the mechanical keying that happens with these foam cores. So we've had to do a lot of development during the development cycle for Airframe 4 to make sure that we can physically lock these structural cores in place within the complex female mold that makes the airframe. Because if any of these beams are in the wrong place, then it means all of your structural pickups are in the wrong place, and your strength, your natural frequencies, and all the other things that really matter for the fuselage won't be right. On top of that, we have to ensure compatibility of the chemistry between the foam system that we're using and also the resin system. We also need to make sure that these reaction injection molded foams meet the flame retardancy requirements and the other compatibility indices that we use to make sure the whole thing works together. Another key parameter, of course, is the fact that we have to make sure that the skins are properly bonded to the foam cores as well, because if they're not, then again the structure doesn't work properly. We can't transfer the shear forces, and we don't get the buckling stabilization of the skins that you'd get if they're properly bonded. So there's a lot of small details that make a big difference to how these things work in practice. And then once that's done, the metallic inserts that we've talked about previously can also be included in the structure. And those are the things that are embedded in those foam cores that you can see on the screen, underneath the skins, bonded to everything, so that we can attach things like your gearbox, your engine, your landing gear to the composite structure without the fasteners simply just pulling through the skin. So let's go and have a look at some of the results of the foam core developments that we've been doing over here. So what you can see here is one of the sort of amalgamated sections of core machining that we've been creating. So you can see floor beams, further floor beams, side beams, some engine bay details over there, and all of these have been nested within a single block of foam. Now, the advantage of this is it dramatically reduces wastage, but purely from a scheduling point of view, it means something like this can be left on the CNC overnight and ran lights out, so that we get maximum utilization out of the machines that we're using to produce these, and it allows us to keep iterating through the structural designs, through the development cycle quickly, without having to stop every iteration and wait for another set of foams to be made. It allows us to work much, much more efficiently. So these foams, as you can see, are made out of blocks of foam in a standard size. They get bonded together, and then once they've been blocked up like that, they go onto the CNC machine, get datumed, and you can machine one side, flip them over, machine the other side. So that's great for prototyping. It gives us incredible flexibility, but of course that's not a sustainable process for us long term. So one of the things that we've been working with our supplier is this little block of foam here has exactly the same chemistry as its big block brother. But this is in fact sold to us in individual chemical parts. So we can actually use exactly the same molding techniques that we've used previously. So it can be glass fiber or it can be carbon fiber, and then we can build up thick laminates using infusion resins, tooling resins, and then from this these sort of laminated tools that we use to produce the airframe, we then can make male and female molds that produce these individual things, but rather than being on a CNC machine for tens of hours, these things can be molded in a few minutes and then released and are ready to go. So as a productionization exercise, this is clearly what we've got to do. And then what you can see here is these are a couple of the examples of the trials that we did while we were developing the infusion strategies for the trapped core structures that we needed to produce Airframe 4. So we've done various configurations of this. We've used configurations that rely on mechanical keying and direct adhesion between the resin system and the foam. We've used alternatives where we use film adhesives and some other magic stuff as well. And we've tried all of these and carried out some basic structural tests on these to verify where we stand. One of the things that's quite reassuring to note is that if you produce a simple sample like this and do a cut-off test, you can see when you look under there that as we pull it off, we're pulling the foam away with us. So we're actually failing the foam and not the adhesion between the foam and the resin. And that applies equally for both the film resin, the film adhesive approach and also the direct bonded approach. So we've got a set of compatible chemistry there that essentially allows us to make these structures even more cost effectively as we mature this stuff into production. So fundamentally, while we're having to progressively move step by step, build on solid foundations to develop what we need to put this fuselage using these processes into production, what we're doing is working and it's delivering at the price point that we need it to. So it's all coming together really well. Let's go and have a look at what else we've been up to. Okay, so Airframe 4. Airframe 4 is the first of the airframes that is essentially a full aerostructure. So this is our monolarge design. It's the outer skin, the structural core foams, the inner skin, all infused in a single shot. Nobody's done this before. This is an incredibly difficult thing to do, and it's actually really quite important to HX50 to produce this structure in this way. So this exercise brings all of these things together. So we've produced over the course of the last 2 weeks, really. We've been taking our time with this one because there's a lot of variables at play. Over the course of the last week, we've developed a full set of structural cores using the new machining methods. We've templated and laminated the A surfaces the cores, the B surfaces. We've mastered the way that you hold the structural cores in place within the tools. We've dealt with the additional challenges of bagging this more complicated shape. We've dealt with a spider's web of plumbing that's been required to get all of the resin and all of the vacuum lines into the structure to be able to produce this in a single piece. And all of those things have come out really well. They've worked really nicely. Still a couple of little things that we can improve, but that's worked really great. The infusion strategy does need a little bit of improvement. And then, with the exception of one minor issue that we had last night with a vacuum leak, we've essentially infused and produced Airframe 4 today. The guys were pulling this out of the molds today. Unfortunately, as a result of the little vacuum leak, some of the B surfaces have slumped in the mold, so we're going to have to reinfuse it. But fundamentally, the guys, Dave actually came scampering in just before we went on air to tell me that they finally released it from the mold, and the strength, the stiffness, and the majority of the infusion has worked absolutely perfectly. So because that is legitimately straight hot off the press over the course of the last 2 hours, what we'll do is we'll produce a little additional update on that towards the end of the week to give you a walk around and show you what Airframe 4 actually looks like. But fundamentally, all of the really difficult stuff seems to have worked very well. A couple of refinements to the infusion strategy, and we have our aerostructure. So really pleased with how that's come together over the course of the last couple of weeks, and congratulations to Dave and Tim and the rest of the team that have literally worked all over the weekend to try and get this out for us today. That presentation's frozen. Making the structure is one thing, but of course there's an awful lot of stuff that goes into the airframe as well. So in parallel with all of the detailed work that Tim and Dave have been focusing on in producing a viable aerostructure that hits the strength, hits the weight, hits the quality, there's a bunch of other work that's been going on in the background. So one of the key areas that we've been quietly working away on in the background is the cabin doors. So we're currently about to start prototyping the forward cabin door, and the purpose of that is once we've got a conforming monolage here, we need to verify the fit, the finish, the gap and flush. We need to optimize the sealing strategy and the seal integrity so that your doors fit properly, so that they sit flush with the airframe, so that they don't leak and let water in or let cold wind in when you're flying around Canada or Russia. And then on top of that, we also have been doing an awful lot of work on optimizing the approach to door locking and the door locking mechanism. As you're well aware, HX50 comes with sort of central locking, as it were, electronic keyless access, but it's a little bit more complicated than that, because we also have to look at how we want the door shutting mechanism to work so that the door will grab, so you can gently execute a sort of quasi soft close mechanism, not all the way to soft close obviously because it's too heavy, but something that gives you the kind of perceived quality you'd expect from a high-end car, rather than some of the very simple methods that have been used in the past. So Martin's been working hard on developing a range of locking mechanisms, only in prototype form at the moment. They'll be integrated much more carefully with the doors as we go on. Let's go over and have a look at the door tool now, and I'll show you what we're going to be using to produce the first HX50 cabin door. So what you can see here is the very first HX50 forward cabin door. Now this is a slightly different approach to tooling than what we use on the bigger parts. This is a model board based tool, and you can start to see immediately some of the challenges you've got with door geometry when you look at the extreme curvature that you've got towards the top and bottom of the door to conform to HX50's very, very curved fuselage. Now the things that are important to us is that the hinge geometry works properly and clears all the seals, so we don't rub seals. But when we close the door, we want the door to grab so that as you then push the handle down, it snugs up against the seal. And the reason for producing this part is we've got a range of seals that we want to examine, just to get the right balance between tight leak protection, make sure that you don't get leaks in there, keep the wind and the drafts out there, but not require such large forces to clamp these seals shut that the door locking mechanism starts to become cumbersome. Now, we've shown you these rapid prototype door handles and things, simple flush fitting door handles for the exterior. You can see down there the little pocket that we create in the door. And all of that is essentially going to be built properly and tested on the first carbon door. And the beauty of this, of course, as well, is once we've got this shutting against the fuselage, we can tune the stiffness of the door and the fuselage to make sure that that sits perfectly flush and gives you that perceived quality that you would come to expect from an aircraft of this kind of price point. So the idea with this is over the course of the next few weeks, Dave and the team will infuse the first door. We've got the windows already made for these, as I think we've shown you previously, so we'll be experimenting with the processes to do the window blackout and to bond on the windows. And then once we've got the door system complete, we're in a position to start experimenting with just tuning the door closure system so that gives you the fit, finish and the feel that we want every owner to experience. So that's what we're up to with the doors. That follows on in parallel with what we're doing with the monolage itself. Let's go and have a look at the tail boom. Okay, so we gave you a little update a little while ago about the tail section of HX50. We'd taken the decision to park this with a mature structural design while we essentially learnt all the lessons on the monolage. The monolage is the most difficult composite component that we have to make, and we were keen to embed all of that learning into the tail boom so it was quick and simple to produce. So all of those lessons have been baked into the design, and also the design of the patterns, the molds, the sealing, the laminating approach, the core approach, and all the infusion. We've now got a stable design for the prototype tail section. There's some optimization still going on, but fundamentally we're ready to prototype that now to validate all of the production processes in the same way that we have for the tail boom. Tim's been working extensively on a much more sophisticated mold setup for the tail boom. What you can see on the screen there is essentially the distillation of our improved pattern recipes, our improved pattern handling approaches, so smaller patterns, more breaks in the molds to make these vast things much easier to handle. We've got a new mold joint strategy that's got much more vacuum integrity, a new sealing strategy, and an improved assembly approach for all of these components. So as you saw in the very early patterns and molds, we were bolting those interfaces together to overcome some of the sealing challenges we've got. With the new sealing approach, we're able to use simple, quick release over center toggles to allow these things to be assembled and disassembled much quicker in production. And all of that now is essentially ready to go. And as soon as we've made the next set of foams for fuselage 5, then we'll be straight onto the tail boom patterns molds to be able to put a full airframe on the shop floor here. So let's talk about GT50 and the engine program. I've been very conscious over the last couple of months that I've been giving you sort of updates that focus on exactly what's going on within the company without taking a step back and giving you a big picture about what an engine development program actually looks like, the things that we actually have to do to get this thing through development, through testing, and into production. So I'm going to give you a little overview on what it is we're doing behind the scenes and why. I'm going to talk about the key technical progress that we've made, a lot of the analysis and refinement. I'm going to talk about a lot of the manufacturing process development that's going on, and then I'm going to give you a production update for what we're doing to make sure we can flow seamlessly into volume production. So fundamentally, development is iterative. It's not a case of the clever design engineers model something up in CAD, we run a few quick calculations and then it's thrown down the stairs to the guys on the shop floor. Every single one of the 3 major parallel activities that we have to do all feed back to each other. So when you design something, you do a lot of simulation using advanced computer simulation methods to assess its strength, its natural frequencies, the aerothermal characteristics, the life, all of these sorts of things. The production guys have to build manufacturing strategies for it. They have to work out how they're going to hold it, how they're going to cut it, how they're going to make it. And when they do that, that in turn feeds back to design. When we go to testing and we look at how we want to test it, what we're required to do for certification, all of those things feed back to design. And so you find yourself in a normal process of going around in loops, refining and refining and refining. And the thing is, what you have to decide as an engineer is, where is it best to solve these problems? Are you best solving them in design, or are you best solving them on the bench? And sometimes it works either way. More often than not, you're better solving them when it's just CAD, but there are instances where it's much quicker to optimize or tweak things on the bench. And in each of those cases, that's what we do. But you have to understand that the way we develop this engine is a very, very systematic approach to design, verify, test, and refine. We build every part, every subsystem, every element of this engine on solid foundations, so that when we put that unit together, we've only got the minimal amount of optimization and things to deal with on the test bench itself. So if I give you some examples of some of the things that have been going on over the course of the last month, I introduced last month that we'd been doing a lot of work on the front end of the engine. The front end of the engine is the primary load path that carries all of the engine loads into the structure and vice versa. We've done a lot of structural optimization here to get the strength right, to get the stiffness right, to get the dynamic stiffness right. We've done a lot of manufacturing optimization here to make sure we can physically make this thing cost effectively. We showed you last time how we'd tweaked the starter generator on the basis of feedback from the maintenance crews that needed to be able to get better access to be able to replace it in service without taking the whole engine or aircraft apart to a significant extent. Since then, we've been developing a refined anti-ice system, a refined core wash system, and we've been developing the blow-through doors that allow your engine to keep breathing if the filter gets blocked. And all of those things lead to improved strength, lower cost, makes the engine easier to maintain, and integrate lots of features that otherwise would have been clunky bolt-ons on the outside of the engine. We've been doing an awful lot of work on the gas generator turbine. Now, originally, HX50 was designed with a very small and elegant two-stage gas turbine. Two-stage gas generator turbine. The beauty of this, it was lightly loaded, it was highly efficient, and it was comfortably within the technology limits for what you can do with blisks. The downside of this was it made the secondary air system, that system in the engine that takes compressor bleed air and keeps all of the important mechanical bits nice and cool, quite difficult to optimize, and we were getting some troubling bearing loads. And so in order to overcome that, we went to a single stage blisk. So we got rid of the first stage, made a single stage blisk, slightly higher loaded, slightly higher disc diameter, so that we got a big enough piston area in the center of it to balance the axial loads. That larger diameter then increased the stresses a little bit. So what the guys have been doing over the course of the last month is essentially moving from a cast blisk to a fir tree root. So a forged blisk that gives us better material properties with the little fir tree roots at the base of the blades to improve our life, our structural integrity, and giving us a direct path to growing this engine into bigger, higher power variants in the future. Now, all of these things are the normal processes that you'd expect in the development cycle of an engine of this level of sophistication, and all of these are progressing very, very nicely. So in a similar vein, if we have a look at the power turbine, we've talked to you previously about how we've evolved to have modern multiple redundant load paths, so that in the event of key features of the engine failing, we're damage tolerant and we can contain an overspeed and a disc burst that would be devastating to the engine. All of that stuff has led to a series of updates throughout the engine, to the oil system, to the drive system, to the bearings, to the squeeze film damper and the spring bars. And then similarly, the latest version of the engine has moved to a forged disc and individual blades with fir trees, again to improve our margins, greatly improve the life, and give us an ability to grow the engine in the future should we want to. So the power turbine, which started as a single blisk, has now gone to a more sophisticated but more capable forged disc arrangement. Similarly, we've shown you previously the work that's being done on the combustors. Combustors are extremely complicated, both in terms of aerodynamics and also in terms of the structural dynamics. These things want to sing because they're so flexible. They have lots of modes of vibration that have to be optimized to make sure that we don't suffer short-term fatigue damage and early life failures in these things. So there's been a lot of optimization of the structural design of the combustor on top of the work that's been done to optimize the combustion and the aerodynamics and the performance. That work has now led to a very, very simple mechanical design that's got the structural dynamic characteristics much closer to where we need them to be, and we've integrated all of the changes that have come from the changing and evolving turbine section into the combustion section as well. Again, minimizing the risk of expensive failures on the bench, improved life and reduced cost and weight for the engine. Now, of course, with us being vertically integrated, while we're developing the refinement in the design that gives us the right basis to put an engine on the test bench, we're also developing all of the processes that we need and putting all of the equipment in place that we need to produce these parts. So for the combustor itself, we've been developing laser cutting, TIG welding, ring rolling, profile forming, pressing, profile expansion, and then CNC laser welding and drilling processes to be able to produce all of these components. Those things are now done, and we are now in a position where we're building the very first combustor. We showed you a lot of the trials of the early components when we were making them at component level a little while ago. That's now evolved to the point where we've issued the drawings to manufacture, and the guys are currently producing the very first GT50 combustor to validate all of these processes so there's no surprises late on in the program. In addition to that, we've spoken at length in aircraft terms about the gearbox development of the main rotor gearbox, the tail rotor gearbox. The engine gearbox, particularly the speed reduction gearbox at the back of the engine, is one of the most highly loaded, fast-moving gearbox in the whole structure, and it's vital that that is properly analysed and lifed before it goes on test. That work has been extensively completed now by Craig. We've got a few details pending based on some material tests that we're waiting back for, but fundamentally what you can see here is the latest optimized version of the gearbox that has removed several kilos of weight out of the gears. The teeth have been optimized, all of the carriers have been optimized, the bearings have been optimized, we've improved the lubrication strategy, and we've improved the general design and sealing design of that whole subassembly, as well as how it fits onto the back of the engine, giving a significant reduction in complexity, a significant reduction in weight, leading to better life, a much more robust lubrication system and a simpler design. What you can see on the slide there is both the latest version of the design as well as some extracted results from the finite element analysis we use to optimize these parts. Again, because we're vertically integrated, while Craig has been optimizing the design, we've frozen the design and we've been producing the first specimens of these gears to develop all of the processes that we need to be able to produce this. So this includes everything that we need to do to produce the high-speed gears. The high-speed gears are currently sat on the 5-axis over there. We've produced the bevels at the front of the gearbox, we've produced the drive shaft, and as you've seen, we've been producing very high-speed bearings in-house over the course of the last couple of months to be able to bring all of these elements together. We've even had to refine, optimize all of the processes we need for heat treatment and plating to facilitate the heat treatment. And all of that is coming together very, very, very nicely. So what you can see here is the drive shaft out of the engine. So this is the gearbox that sits on the back of the engine, reduces the power turbine output from 36,000 RPM down to around 6,000 RPM. That drive shaft is what powers your helicopter and what powers your tail rotor out the back. We've developed the torque sensing and the speed sensing systems. We've optimized the weight of this, but of course, getting the weight out of these components simply pushes the problems onto the manufacturing guys. So what we've had to do here is produce a test shaft just to demonstrate that we can physically make this to the tolerances that the design team have asked for. So again, being vertically integrated, that goes on right over there and has been done successfully. So the structural design called for really thin walls. Production then becomes the limit, not how thin you want the walls to be, it's how thin you can actually make them. We've carried out the production trial, built the drive shaft, and that's sat on the bench over there being tested at the moment with the sensing system. And we can go over there in a second and have a look at how that works. There is, as always, still some process refinement to do. The surface finish isn't quite there yet, but fundamentally, everything that we need to deliver the drivetrain for the GT50 is now under control in-house, and we're producing all of the components from the output shaft through the drivetrain to the drive shaft. And let's go and quickly have a look at some of those components over on the bench at the moment. So we've got a selection of the in-house manufactured gears here. The planetary stages, first stage and second stage that you've seen for the main rotor gearbox you've seen previously. We showed you those a little while ago. These two bevel gears are the bevel set that sit at the front of the engine and essentially take the drive from the transmission shaft under the engine and then up into the main rotor gearbox. So the drive shaft drives up through that aperture into the main rotor gearbox over there. So what you can see over here, we've had a number of questions over the last month or so on how the torque sensor and how the speed sensor work. So this is the drive shaft. So this validates the fact we can make lightweight, high performance, very, very thin walled shafts with the necessary splined ends and timing features on the end. The way that the torque sensor works in this engine is essentially we're detecting how much this shaft twists as the torque goes up in the engine, and we measure that through the phase of these against a static reference shaft. And then in terms of how we measure the speed, the rate at which these lobes pass a speed sensor is what gives us our speed detection. And what you can see over here is Martin has rigged up the speed sensor that's going to be fitted in the engine. It's attached to an oscilloscope, and what you can see is as the signal passes, if you look at the screen, as the lobe passes, we get a detection, and then it goes back up again. Okay? And it's that detection that the software counts, and that's what gives you both your speed sensing and then the difference of that in relation to a fixed sensor is what gives you your torque reading as well. So that's the drive shaft. So a lot of development going on upstairs in the design suite, but there's a lot of development in parallel building these parts that we need for the engine on the shop floor so that we've got them there ready to go as the last couple of bits of design get completed and allow us to pull the last parts of the engine together. Okay, so let's talk briefly about the digital cockpit. We gave you a big overview over the last couple of AMAs on some of the work that's gone into refining the user interface, refining the connectivity with electronic flight book apps, the latest functions in the IPI, and the latest styling refinements on that cockpit and user interface. Those activities have now been parked temporarily while we focus on the detail that goes behind the scenes in the UI. There's a little bit of further refinement on the user interface to do. This is largely from customer feedback that we've had by engaging with the customer base, and this is to do with making the traffic displays a bit clearer on the primary flight display and potentially improving the readability of the airspeed as well. But at the moment, the fundamental focus is now on the software development that needs to go on behind the scenes to deliver this as a certifiable product. So Eric's been very busy developing the real-time operating system, the graphics drivers, and all of these things, and then we'll shortly be shifting to some of the less critical functions like the infotainment, the logs, and the app integration. Eric himself is now focused almost entirely on moving the software that we've got to target hardware. The avionics bench over there has got the actual hardware plugged into it that will be running the DigiCockpit software, and Eric's gradually building up the systems, the graphics configurations, the graphics drivers, working very closely with the vendors of the hardware and the software to make sure that we pull in the latest best practice to build an absolutely solid working base for the DigiCockpit. And I think as we stand at the moment, we're about 1 week away from deploying everything that you've seen so far in terms of the DigiCockpit PFD on to target hardware. So there's a big update coming on that shortly once we've got it running from target. One of the keys about the, sorry, I'll go back for 1 second. One of the keys about the target hardware, of course, is a lot of the things that will be layered into the DigiCockpit, such as the use of the transparent layer behind it for camera feeds and for synthetic vision, are platform dependent. So until we're on target, we can't finish implementing those last couple of cherries on the icing of the cake. So that's what follows once we've got ourselves deployed properly. Let's talk briefly about the infrastructure to support the build. As you're aware, we're building a 350,000 square foot production facility to allow us to build 500 HX50s a year, ramping up sometime later as and when required. The planners have now given us a commitment that they will make a final decision on the planning application by the 9th of May. They've delayed this slightly simply because there are local elections going on in our area at the moment, and they don't want such a big project to be used as a political football. So that's a little bit frustrating, but I think it's a necessary evil to make sure that we have a smooth transition through the process. We've provided all of the support we can, all of the documentation's in. We're completely convinced we have a completely compliant bid, so we're looking good on that front. We just have to allow this process to take its course. And for those of you that watch Clarkson's Farm, it does feel a little bit like that at the moment, but I've got no doubt we'll get a happy ending at the end of it. So in the meantime, obviously building a big box is just one part of this. There's a lot more work goes into developing a factory of that scale than just building the building that you see on the images there. Myself and Mark and his team are very focused at the moment on producing all of the procuring all of the production equipment we need to produce this vast array of components to the right standard, to the right quality, in the right volumes on day one. And so over the course of the last 4 weeks, Mark and myself have been traveling extensively, meeting with the various suppliers that provide this equipment, because a lot of this stuff is still on 12 to 18 month lead time. So it's really important that we get these orders placed now so that we've secured our place in the queue. Some of the equipment that's coming in to support the prototyping exercise at the moment, we've produced a second lathe because we're about to get a huge tidal wave of turned components for the engine prototype. Our longer weighted CMM that's required for bearings and gears will be arriving next month. And then we've recently purchased the SurfCon and the RonCom, which are the very, very, very accurate measuring machines that are necessary for producing super high performance bearings. All of that equipment will be here within a month. It's all purchased, it's all on its way to us. There are other items of equipment that we've been sourcing over the course of the last couple of weeks in particular. Some of it is the very specialist equipment you need to be able to produce bearings. We've been over in Sweden working with a specialist organisation over there to secure the equipment we need to make ABEC 9 standard bearings, so the very highest quality bearings that money can buy. We've selected the equipment we need. As you can see, it's a very, very sophisticated piece of equipment. It's robot fed, so that even though our volumes are relatively small, the machine has the flexibility to be making one type of bearing one day, and then after a quick changeover, another type of bearing the next day. So the 38 different types of bearings we've got on the engine can all be manufactured on those two pieces of equipment there in a lights out, unattended fashion. It's very, very, very sophisticated, high volume stuff. And then to support the move to the bladed disc on the turbine, we've also been looking at some EDM equipment and some Viper grinding equipment to get those fir tree roots into the engine quickly and inexpensively. So with all of this stuff going on, it should come as no surprise that sales continue to be extremely strong. I think we approached 50 sales since the last AMA. Sorry, we exceeded 50 sales since the last AMA. We're in 56 countries. We've now sold 637 X's and 141 C's. We still have a growing sales pipeline of people that are just waiting for their own criteria to be hit before they jump in. So there's never been a better time to join us and get on board with what we're doing here at the company. So at that point, I'll pause for breath and open the floor to questions. The only other point I'll make is we've received some questions from customers and some prospects asking when the next event's going to be. We will be announcing the event and the location at the end of the month, this month. So not long to wait now until you find out when you're going to get to come and sit in the very first HX50. Thank you for your attention, and I'll now open the floor to questions.
Fantastic update, as always, Jason. Great to hear. It was 47 minutes of packed information. And now we have the chance of asking questions to Jason. And we already have about 40 of them. We usually can handle about 70 during an hour. So I encourage anybody that wants to ask anything, just put the question on the chat. We'll be adding that. We'll be closing this session exactly in 1 hour and 10 minutes max. So the first question, Jason, will be from Adam Fawcett. He is asking a very straightforward question. He says, I love what you're doing. It's inspiring, and I really want to place an order. That's good for you, Adam. Adam, that's a good decision. What are the assurances you can give me? Right? Okay. So before that, before he gives it the yes, Jason, he has a question. What are the assurances that you can give me that I won't lose my deposit and I will be ending up with a helicopter?
So from my perspective now, there were some very brave customers that came into a very empty restaurant back in August 2020 and signed up for a HX50 when we were a much smaller company than we are now. And at this point, we have an order book of, I think it's £308 million. We have huge financial resources. There are no technical obstacles that will prevent us from delivering this aircraft. 20% of the customers that have bought aircraft have offered investment all the way through the journey. I still own the entire company, so no matter what happens, we're never going to run out of money. The only thing that could stop us would be running out of money. Everything else is in hand. So from my perspective, there is no danger that this helicopter won't be delivered. We will absolutely deliver this helicopter and many products to follow in the future. As with all development programs, the risk that you take and the risk that's very clear in the contract is that it takes a little bit longer than we say it's going to take. That's the only material risk that you face. But fundamentally, if you're not ready for that, the answer is quite simple. We'll welcome you whenever you are. You don't need to buy one now if you're not ready. Come back in a year, come back in 2 years, come back whenever you feel comfortable. But my advice would be, in my honest opinion, nothing will stop this getting to market. We're in such a strong position that nothing will stop it. So it's a question really for you. How long do you want to wait?
Okay. Very good. Next question, Jace, is from Darren, and he's asking a simple one. Can we visit the factory?
Of course you can. We do tours twice a month on a Friday morning. If you contact claire.barber@hillhelicopters.com, she'll get you booked in.
Excellent.
Okay, next question. It is from Herinder. He says, when will the first physical product be ready to see? And can we visit the factory already? Answer that part. When will be the first prototype ready to take flight? And when would we be able to see it?
Well, you can come and see where we are at any time, as we've just said. The first flight is scheduled for the end of this year, so the prototype will be together hopefully by the middle of the year, and then the whole thing together by the end of the year.
Excellent. And next question is from Dave. You can answer it if you like to, or we can, whatever you like. Will you have displays set up at air shows such as Oshkosh and so forth?
We will, yeah. There's no point in us being there until I've got the rest of that put together. But as soon as we've got an asset to take round to these shows, we'll be there in force.
Okay. Excellent. Philippe has a bold question. It says, this may sound as a strange question, but regarding continuity, what happens if Jason dies? How is supposed to be, what's supposed to happen with the project?
If I died, my wife and kids would be devastated. That's the main thing. We've built a strong team around me. I know I front these Q&A sessions, but there's now a very, very strong team of very, very experienced professionals behind me. I think it is fair to say that as with any startup, which is essentially what we are, there's a huge dependence on the founder for the first few years. I think my technical direction, my commercial direction, and my sort of drive and vision for the product will be important for a little while yet, but we're so far down the line now that these wonderful people that work with us on the project could get this delivered without me in the not too distant future. So yes, it is a risk, but it's a risk for anybody in this sort of position with the business.
Okay. And Don is asking a question about the fuel tank. So it's a 175-gallon fuel tank. He says, I'm estimating it'll cost between $1,200 and $1,500 to fill up a full tank of fuel. Is this correct? Is this a correct calculation? So in the meantime, I did a little bit of calculations based on average prices across the US, just as a ballpark there for the US. And you're looking between $900 and $1,200 US to be able to fill the tank. There's better prices than that, and there's a little bit higher prices than that, but $1,200 should be sort of on the high end for filling it up. So that's obviously based on US dollars.
Yeah, so for UK owners, I've just done the sum based on what my friend Martin pays for jet fuel to his Bowser at home, and it'll be about £550 to fill the tank. So we can buy jet fuel quite cheaply over here. So yeah, not quite so bad in the UK.
If you're buying it from an airport,
well, if you buy it from an airport, it's going to be more expensive than that. But for people having fuel delivered at home, it's pretty cost effective.
Yeah.
Okay. Almost tempting to go and fill the UK at UK and come back to North America. All right, and from Sean, we have a question about delivery of a specific range of serial numbers, Jason. So taking into account what you just shared about the timeline, can you give us the rough estimate, given that when will the serial number 250 to 300 will be ready for delivery? So estimates on that.
So based,
and also you can jump in on the capacity of production as well, integrated with this, right?
Yeah. So production capacity will start at 500 units a year. The reason Mark and I are doing all this work at the moment is so that when we've got to build the prototypes, we've got to build what we call 0 series, which are a few airframes to just develop the production facility at volume, and then when production starts, it will be designed to produce 500 a year. There'll be a very small ramp up, but it will be 500 a year in that first year. So if you're at 250, you're about 6 months into the first year of production. So on the current timelines, the latest that would be summer 25. Summer 25.
5.
Exactly. Yes. Good. Okay. A question from Ricardo from Brazil. It says, what guarantees can you give us that when the helicopters are delivered, they will already have the American flight certification?
Well, fundamentally, we are not entirely in control of that because we're in the hands of the US authorities. What I can guarantee you is that Hill Helicopters will have done everything that's required of it and will have done it in good time to be able to facilitate that. We've said all along that for all of the territories that we've sold into, we will do the stuff that goes on behind the scenes with the authorities. We will seek the approvals, pay for the approvals, so it's as streamlined a process as it can be. But if you look at any aircraft program, the the authorities can sometimes be a bottleneck, and it varies around the world. In terms of the US, they're generally very good, so I fully expect that one will be quick.
This is for Brazil, Jason. This is for Brazil.
That is for Brazil.
The specific one.
Did
But
you
he's
say
asking about
specifically?
American certification.
I think he was asking for the US, wasn't it? US should be very streamlined. The regulatory framework we're working with there is very compatible to the primary basis for approval in the UK.
Okay.
Mm-hmm. Okay. Connor Nolan, he has a couple of questions. One is, I want to go surfing Cornwall with my daughter. Will I be able to strap a couple of boards under the carriage, into the undercarriage? That's one. You can answer that one. And then we have the second one, which will be, we want to keep the helicopter in a friend's field, lovely Cornish weather, often chucks down rain. Is there a cover or waterproof sleeve that we can put and protect the helicopter as an option compared to a hangar?
I would wholeheartedly advise you not to keep it in a field. There's a lot of precision engineering in helicopters, and while these machines are composite, while they've got the latest corrosion protection approaches and a very, very robust approach to that, fundamentally it's not a good idea to keep an aircraft permanently outside in British weather. It's just asking for trouble. So I'd wholeheartedly recommend you keep it in a hangar. Short term, overnights, long weekends, weeks, things like that, fine. But if you keep it outside permanently, you're just storing up maintenance problems for it when it gets a little bit older. So I wouldn't recommend you do that. In terms of covers, yes, we'll be working with a variety of providers to provide covers, both in-house ones and aftermarket ones.
And what about the surfboards under the helicopter?
Surfboards, we've got one of our very early customers made me promise to make the front passenger seat removable so that you can keep them inside the cabin. So we should be able to fit surfboards within the cabin. In terms of fitting it outside, if you've got skids, it might be possible, but again, it's really not. It's not something that we can just say yes to. It's something we'd have to do a lot of work on. So I'd say for that, if it fits inside, yes. Outside, I wouldn't guarantee it at the moment.
Okay. Brian is asking, he's from New York. I was wondering, in the future, will people be able to come and get their helicopter license at your facility?
We'll be doing type ratings to start with, and we'll be doing sort of some training in the UK to support the rollout of the program around the world. But I'm very mindful that I don't want to displace people in the UK that have built businesses providing flight training. I'd rather support and nurture those, because that's what we'll have to do around the world. So yes, you'll be able to come and get some flight training around us, but we will also have a range of independents that have the benefit of all of our training materials and our support to deliver flight training close to you.
Okay, next one from Sean is curious about what is the fire suppression system that will be used in the cabin?
There will just be a fire extinguisher in there, basically, as part of the equipment where it's required.
Okay. Excellent. Next question is from Clive, but just a comment before that. Somebody was asking a little bit more about fuel tank size and range and so forth. So I just want to direct them to the website, the Hill website. We have a range configurator on there, so you guys can jump on there, play around with a little bit of different configurations of how heavy the passengers are, how much fuel you want to have on board, and then it gives you a circle, basically a range geographically of how far the helicopter can fly based on that configuration. You can move that around to anywhere in the world if you want to. So if you have questions about how many miles it'll fly and so forth, jump on there, and I think you'll really enjoy that. So the next question I have is from Clive, and it says, are you developing a 2- or 3-axis autopilot, and is there a hydraulic system or an electric SAS system? So somebody that probably hasn't been following the whole program, but why don't you give an update on that, Jace?
Yeah, the aircraft comes as standard with a 2-axis autopilot, and it has a mixture of hydraulic inputs and also electric actuators on the flight controls. It is not the same as the Genesis system. It works very differently to that, but fundamentally the modes are common to most aircraft. So your 2-axis system will give you stability augmentation, altitude hold, heading hold, nav following mode, and another one which I can't remember, speed. And then the 4-axis system gives you your your damping and your control, as well as some inputs to the collective as well that provide some higher functions. So I've said all the way through the program that our 4-axis autopilot is very, very, very keenly priced. It's priced at about a quarter of the nearest competitor, and the reason for that is, of all the options, I would suggest that people take the 4-axis autopilot because it is game changing. So yeah, both options are available. 2-axis is standard, just to make flying easier and more enjoyable.
Regarding the flight autonomy, which we already covered, but I think there's a little detail here that could probably give more information for everybody. Is there any concrete data about this? I think he's referring that how can we actually calculate the autonomy of aircraft, this estimated flight hours. So the data that you work with, can you elaborate a little bit more on these calculations at this stage, Jason? How we get to know the autonomy of the aircraft at this stage, and how we can, from where do we gather this data?
The autonomy of the aircraft. I don't really understand the question.
Autonomy meaning flight hours. How many hours could it be? You know, the fuel burn rate, and obviously the speed that the aircraft has, that will give us the autonomy also in terms of range and also number of hours.
The fundamental performance characteristics, is that the question?
Yes. How you calculate that?
Okay. Well, the thing is that while this helicopter looks very new and very Gucci, it is in fact like a greatest hits album. It's all of the bits about helicopters that we know and understand very well brought together, and what we've actually done is a very good job of industrializing the helicopter. So the rotor system is based on some technology that's very well known and very understood, as is the engine, as is the aerodynamic principles that have gone into the design of the aircraft. And so fundamentally, nothing is new here. We're comfortably within the art of the known. What we're doing is just displacing a supply chain that's become unsuitable for general aviation, and delivering an aircraft at a better price point. So the tools that we use to do the comprehensive analysis on the flight performance, for example, these are extremely proven tools that have been used in the industry for decades. And our team have been involved in all of the or have experience of many of the big name programs that have happened over the last few decades. So we have a huge amount of confidence, a huge amount of experience in delivering each of the elements that goes into making this aircraft what it is. And then in terms of what we actually declare to the customer base, we've obviously left ourselves some margin. I don't expect to be tight against any of the key performance parameters. We've under-declared all of the things that I think you're going to care about, so that we can be sure that we hit them when the prototype has finished its test flying campaign.
Wonderful. And Giuliano is asking, are there any plans to have the rear seats removable in order to allow larger baggage or cargo transported, such as bicycles, for example?
Yeah, the rear seats are easily removable, and the floor has tie-down points, so you can put what you want in there as long as it conforms to weight and CG limitations.
Excellent.
Clive Edwards is asking, are you running ducting through the foam to conceal and protect the wiring looms?
We do a lot of things to protect ourselves from EMC and HERF and various other things, so there's a lot of stuff goes into that composite structure to protect against those sorts of things.
I think the question is directed a little bit more towards the wiring looms that have to run through the aircraft, from maybe the displays to different parts of the aircraft. Will those be running through the foam? I think it was the question. Are you going to have tubing that goes?
No. There's again, one of the things that we have to do is design this aircraft so it's easy to make, okay? And so when we produce this aircraft in the factory, it sits on a big rollover rig, and the idea is you want to do as much as you possibly can from the outside. So we roll this thing onto its belly. There's an access panel on the bottom of the fuselage that allows us essentially to lie the wiring loom outside of the primary structure. So it's easy to get out for maintenance, it's easy to fit, and it would be easy to repair. if it develops problems in 20 years' time. So no, we don't bury a lot of, we try not to bury anything in the foam cores. The only exception to that I can think of off the top of my head is we've embedded the antennas for the comm radios in the vertical end plates of the horizontal stabilizer. And that's just to keep them off the surface of the body, keep the thing aerodynamically clean and visually free of clutter. But again, that's an established approach that many manufacturers use.
Okay. The next question is from Tennis, and I think it's a question directed a little bit more at Ruben and I. So basically, once production begins, how many flight hours are we planning to do before we start our around the world trip? I don't have an exact number of hours, but I know that we are going to spend a good amount of time flying around the factory in close proximity there, just getting comfortable with the aircraft. But then we're also going to be spending a lot of time flying around Europe and just staying kind of close in case we need to head back to the factory for anything before we actually start the actual world tour.
And again, please understand that the machines that Ruben and Mischa are talking about are series production machines. There'll be 5 pre-production machines or out-and-out prototypes, and then there'll be a few 0 series machines built in the new factory before we produce anything for a customer. So the prototypes themselves will have accumulated a large number of hours before those machines go out, and we will always maintain the fleet leader. So our machines will always have more hours on them than any custom machine, certainly for the X's. And by the time the C's get out there, that will be the case for the C's as well.
From Kyle, we have a question from Ohio. Is there going to be more discussion on the retractable rotor blades for storage design, and if automatically controlled? So you can develop more about the...
At the moment, there's been some comments flying around on various mediums about the lack of discussion on the rotor system. Now, I've addressed this in some of the previous AMAs. The reason for that is we're doing a couple of things up there that are very clever that we haven't patented yet. The rotor mechanical design is frozen. The blade design is frozen. We're going through a very extensive optimization process at the moment, just tweaking and refining it. But there's a couple of key features up there that are really important to our drag and our aerodynamics that I can't declare yet until we've got proper coverage on them. So that's the only reason I haven't said more about it at the moment. In terms of the blade fold, it's at the moment the blade fold system is a simple mechanical system that involves popping a pin out outside of the rotor fairing and swinging 2 of the blades back over the tail boom. You've got easy access up onto the engine deck. It's easy to swing the blades back, and then there is a stay under the tail rotor drive shaft cover that allows you to connect to the back of the tail rotor blades to protect them in gusty weather if the machine's outside for any reason. So blade fold is a very, very straightforward option. The rotor design inherently allows for it. A motorized blade fold system would be a much larger undertaking. We've indicated that it's something that we're going to look at, but we haven't done that yet, and it's a little way down the priorities list at the moment.
Okay, good. Yeah, a lot of people ask that question even in our presentations that we do, and questions revolving around, will it reduce the life of the blades, or is there safety concerns or anything like that? So it's good that you're addressing that.
It has no impact on that. The one thing that you have to be very careful about with rotor blades is what you do with them when they're not spinning. All of their structural integrity is derived from centrifugal stiffening. So when they're just hanging there, it's very easy to damage them, so you do have to be very careful with them. That's not something that's specific to us. It's the same for the big helicopters, the military helicopters. You have to be ever so careful with your blades when they're not spinning. But the processes that we've developed are robust, and there's no reason why that shouldn't be safe, and it certainly won't impact the life of the blades as long as you execute the procedure properly.
Perfect. Next question is from Atle, and it says, will it be possible to connect ski baskets if you have the skid version?
Again, we've done nothing with that. Yes, technically it's possible. We could do it. Obviously, we've got a much slipperier helicopter than most people. So if you start putting big things on the exterior of the helicopter, it is going to hurt your cruise speed quite a lot. But yes, fundamentally, we're open to developing those options down the lines. The C model in particular needs to be every bit as utilitarian as some of today's machines if it's to be successful.
All right. Emilio is asking what are about the current sales numbers and how many slots have been sold to date. So today we have 638 HS50s ordered and 144 HC50s. So that's the total number of aircraft ordered today. And today you can order still the aircraft with a substantial incentive. With a 30,000 pound deposit, you get a 98,000 pound discount. So locking in the aircraft's price, the final price at 497,000 pounds instead of the 595,000. These conditions are available for the next 2 serial numbers. So that one is done, and the question is, you can go ahead with the next one, Mischa. Go ahead with the next one, please.
Sure, yeah, from Keith. I think I understand the question, but I'll just read it and see if it makes sense here, Jason. Is the current height of the airframes the height of the finished aircraft with skids or wheeled version down?
No, it's 100 millimeters, so it's that far higher than the real one will sit. So they're sitting a little bit high at the moment. So it's about, what's that? It's about 5 inches too high.
Yeah, I think that's where the question was geared towards. The ones that we're seeing there behind you, are those the actual height? So
no, they sit a little bit lower than that.
Okay, Clive has another question. Will the HS50 be operated at 12 volts or 24 volts?
28 volts is the current voltage, I believe, off the top of my head.
There you go. 28.
And Jerry is asking a question. Looks like everything is going very well. Do you feel like you're on schedule for your deliveries?
Yes, I do at the moment.
Daniel, do you plan to eventually have HS50 owners group meetups, fly-ins, or maybe even curated travel destinations at some point? A little bit about
Absolutely.
the community and the plans to.
So I guess if that's we have a customer app, and so we're already doing that to a very significant extent in that we're connecting all of our customers. We have a vibrant international community of like-minded people in 56 countries. The first job for Hill Helicopters is to create a helicopter that people aspire to buy, and the second job is to make sure that we create this network of people that enable you to continue enjoying being a helicopterist, you know, and so being connected around the world, having a community of people that love owning, operating, flying helicopters is central to what being a general aviation company is all about, and central to what our sort of GA 2.0 strategy is about. So yeah, absolutely, we're actively going to make it as easy as possible for people to get the best benefit they possibly can out of their machines for an extended period of time.
Excellent. Yeah, I look forward to that. It's going to be a lot of fun. Clive is asking a question. Do you have any test pilots that are earmarked already at this stage for doing flight testing and limitations?
We've had a lot of job applications. So yeah, we've got a number of people that have put themselves forwards. Ultimately, the final decision will be made by us and the CAA. Because we need the most streamlined process through approvals that we can. So it needs to be someone that's very much in favour with the authorities and trusted by them. So no, we haven't formally earmarked an individual, but that won't be a decision we make solely on our own.
Okay, Gene is asking a question from the U.S. customer base perspective. And he's asking to explain a little bit how the VAT works. So is there VAT applicable or not? So to be very clear, the VAT is a sales tax for the UK. It's very similar to sales taxes you have in the US. So when the aircraft is exported, no VAT is applicable. So this is nothing you have to be worried about. You're not going to be paying any tax from the origin if the aircraft is to be exported. It's only for local clients, they have to comply with the local VAT, and then you're responsible for any local sales tax when you import your aircraft to your own country. So that one is clarified by itself. Now, can you have a review of the financial planning of the project from development through delivery of the early models? Where is the revenue coming from, and how expenditures are being budgeted out of your own development process? Are you on budget, Jason?
We're well below budget. We're well below where we thought we'd be. We've got much more resource than we thought we'd have. When we set out to do this, we set out with the hope that we'd sell 100 helicopters before we flew. So we're in a fantastic financial position. So yeah, we're very, very robust financially. The burn rate's nice and low. The bank balance is very strong. Even now, the bank balance keeps going up, you know, despite where we are in development. So to be in that position pre-production is incredible. So I'm very robust about the financial position of the company.
And the revenue is coming from, it's part of his question, the revenue is coming from, Jason?
Yeah, the revenue is essentially coming from sales deposits, non-refundable sales deposits at this time.
That one is clear. Go ahead, Mischa.
Excellent. Noel is asking the question, are you going to forge the gas generator parts in-house or buy them?
It'll be in-house. There are some, we'll buy some forged stock, just because that's the most convenient way to do it. I don't expect to have a big drop forge here. No, I think there are places where we can buy those, the materials that we need at a reasonable price. We don't need very much of that sort of material, so I don't expect that's going to be a problem.
Okay. Next one, how will the ADs be handled? Updates, firmware updates to be conducted when the product is in hands of the clients. Historically, a Part 145 or OEM would conduct these improvements?
Yeah, so fundamentally, if it's non-flight critical, if it's on the infotainment side of the platform, we'll do that via over-the-air updates via the Hill app. If it's anything to do with flight critical software, then that will be done through either the maintenance and distributor network or the factory. So much the same as what you're used to.
Okay.
And then, sorry, in terms of ADs, the single point of contact for everything to do with Hill will be the Hill app. So everything you need to know about the community, the status of your machine, the status of your licensing, anything that's being pushed out as safety bulletins, airworthiness directives, any information to do with your aircraft or your ownership experience will come through the app, so that everybody is fully informed all the time.
Okay. We have Octavio asking a question here. He says, from what year do you start deliveries in Brazil? And just for reference, our first order in Brazil is serial number 137.
So that'll be very early in 25, won't it?
Okay. Next one is from Ty. Have you looked into offering an ownership share program similar to Diamond Aircraft? I would think since you are still in this pre-manufacturing stage, you could easily put interesting buyers in touch with each other and filter them through the geographical area interest.
So we have done this, we do this, but we do it relatively informally at the moment. We have a number of syndicates all over the world. We have a British syndicate, we have a New Zealand syndicate, we have a South African syndicate, and the startings of a Norwegian one as well. Off the top of my head, I think we might have a few more. But there are people out there that do syndicated ownership. We support it fully. Again, we have to focus very much on the moment on the core mission, finishing that, making it fly, putting it into production. So we have to be very careful with what we take on internally with the limited resources we have. We wholeheartedly support syndicated ownership. We think it's a great idea, and we will facilitate more of that in the future through the app and through the community. But at the moment, it's not something we're actively pushing, though we do support it.
Okay. Next question is from Noel, and it says, what are the contingencies if planning is refused? Is there any plan for a more limited facility elsewhere?
There's plan B, C, D, E, and F, but it's not really appropriate for me to talk about them with an active planning application going through. Nothing is going to stop me putting this helicopter into production. We could rent places, we could build elsewhere, we could do lots of things. We could put a network of these sorts of facilities together. There's lots of things. None of them are as optimal as having a bespoke facility in the right location. But don't worry about that. I'm not sat here twiddling my thumbs, waiting and hoping. We've protected our interests.
I think that's very good answer and very clear, because sometimes there is some speculation. If this one doesn't work, well, how much of this thing is compromised? Well, Jason is not sleeping even at night many times, so be very, very clear that the plans are there, whatever happens. Next one is yours, Mischa, is it? Was it mine?
Yeah, let's go with Joe. So Joe is asking, he does a lot of flight simulator flying on many different models, including the Airbus H145. And he's asking, do we have any updates regarding the HX50 coming to Microsoft Flight Simulator and X-Plane? We actually had some recent discussions on that. So you want to give any updates on that, Jace?
So we almost have, so we are doing at the moment a updated dynamics model. So this is the actual aerodynamics, the actual dynamics properties, all of the aerodynamic coefficients, all of the algorithms for the flight control laws that are being developed on our in-house engineering simulator over there. And we will make those available for people that want to develop Microsoft Flight Sim stuff. There is some X-Plane stuff going on that we're aware of at the moment, and so this stuff will be coming. Again, it's not something that I'm personally driving at the moment, but I do see it as a beneficial thing for the company, so we'll wholeheartedly support it. Mischa or Ruben, Paolo showed me some X-Plane stuff the other day. Do you know any more about that?
Yes.
Yeah, we've got some really exciting stuff going on there.
Okay.
We were able to see some of the updates that were happening with X-Plane, and we're actually very, very close to being able to complete that project. So I wouldn't be surprised if we, I'm not going to give any dates, but if we see the HX50 on Microsoft Flight Simulator and X-Plane coming in the near future, which is going to be a good benefit for people to see the aircraft and be able to test it out and fly it at home, but also at the Hill facility to be able to do it on an actual simulator with the cockpit and everything there, and then at trade shows as well. So it's going to be really great. Yeah.
Be able to really experience that aircraft in simulator soon. Next one has been addressed a couple of times, but I think it's better from the point of view of making it even more clear and for the ones that are just joining the program. And the question is to cut costs and reduce liability. Look at this one, Jason, the details, reduce liability, and to speed up the process. So liability and speed, why not use your outsourcing like comparable industries have been doing? So that's one that is in your very clear realm.
Yeah, in very simple terms, you can't get anywhere near the price point that we're producing this helicopter for if you go to the outsourced supply chain. And then on top of that, you can't do the things that we're doing if you go to the outsourced supply chain. You can't buy a digital cockpit like our digital cockpit. And these composite structures that we're producing here would cost an absolute fortune if we were to try and outsource them. If I was to try and buy a helicopter, if I was to try and buy an engine, it would cost almost as much as we're trying to sell the helicopter for to buy the engine. So it's just not an option. Our ambition for the business is to make helicopters more accessible, more attainable, and more affordable than they have been, and not a bargain basement helicopter, the kind of helicopter that you'd want to own. And to do that, we've had to vertically integrate. And we vertically integrate for lots of reasons. It expedites many aspects of development, and it gives us the ability to provide low-cost insurance. It gives us the ability to provide low-cost part support into the future. It gives us whole life cycle control of the costs of the aircraft. So fundamentally, you wouldn't get anywhere near that working with the outside supply chain. You have to do it yourself. So yeah, it's just not an option if you want to get to our price point.
Okay. Next question is from Nico. I'll read the question and I'll give a little bit of preface to it just so you have a little bit of understanding behind it. So it says, is the ceiling going to be set at 10,000 feet, or can it go a little higher since we're in the mountain areas? So I think the reason that that question is coming up, because the performance numbers that we're declaring all the time is that you can take the aircraft at full gross weight up to 10,000 feet on a plus 15 degree ISA day up there. We're going to be able to hover out of ground effect and still vertically climb out of a confined area at about 300 feet per minute. Now that's very different than the service ceiling of the aircraft and what it can actually fly. So why don't you go over a little bit of that performance, Jason?
Yeah, so the power curve for a helicopter, as you're probably aware, is a bucket. And the two most difficult things you can ask a helicopter to do, hover out of ground effect at high altitude at max gross weight on a hot day, and fly really, really fast on a cold day at sea level. Those two things consume the most power. And so when you're defining the performance or the limiting performance for a helicopter, what really matters is what is the highest that you can hover out of ground effect, because that tells you the highest that you can get into a confined area. And so that's what we've based it on. However, when you're flying at normal cruise speeds, your power requirements are a lot lower. And certainly if you bring the speed down to anything up to about 100 knots, then we have a very flat bottom to our power curve because the aerodynamics of the fuselage is so streamlined. So at those sorts of powers, you're using a fraction of the power it requires to hover. And so you have a huge capability to climb further, and you have an ability to fly much, much higher. And then in terms of the main rotor design, we've actually just been looking at some extreme cases, some extreme altitude cases for the rotor. And it'll fly much, much higher than that. I think you're not going to have a problem at higher altitudes than that, let me put it that way. And the hover ceiling we've given, again, is conservative.
In the declared service ceiling at the moment, just for clarity for flying over mountains and things like that, at the moment the declared service ceiling is 17,500 feet. And so that's for if you're cruising, if you're transiting from point A to point B, and you need to be getting over high altitude mountains, that's the number that's concerning for people. So it definitely will fly higher than the 10,000 feet that we're talking about.
And I would just add to that the rotor and the engine have meaningful performance, notably higher than that. So there's margin there as well. We'll get to what the highest height above ground is, because obviously that's often a fire consideration, how quickly you can get back to ground. And so there's all sorts of operational limits that will consider how high you can be above the ground versus altitude. But you're really not going to be short of performance in this machine.
Good.
Okay, next question is a short, direct question from Umberto. When will the first engine run?
We're still aiming to have that running in the summer this year. That's the plan as it stands at the moment.
That's northern hemispheres. For the friends that are in southern hemisphere.
Yes, that's a good point. I'm in the UK,
September,
so that's it.
Yes. Okay.
Okay. Elaine is asking, how do you evaluate the combined risk of all new design parts, including engine, drivetrain, etc., failures? Every new helicopter I bought made by Bell Augusta presently presents several critical problems on the first commercial models.
Okay, well, again, it's a multifaceted strategy. So the first element is, again, we're not inventing anything new. This is a greatest hits album. So we're taking proven concepts and we're industrializing them very well, making them with the finest equipment out of the finest materials, and then developing them on the bench extensively. So before the first helicopter rolls out of the factory, we will have cleared the declared life on the bench, on the ground, with measured flight loads. We'll have also ran an extensive program of shakedown testing where the 3 first prototypes will be taken to all sorts of climates and locations and given the hardest time we can possibly imagine to find all sorts of innovative ways that we can break it. And so we will robustly evaluate and shake down the aircraft before customers start to receive their aircraft. The other point I would make is every HX50 goes out of the door with a 5-year, 5,000 hour warranty. So those early series production problems are my problem, not your problem. So for as long as the aircraft is in warranty, you're not going to be exposed in the same way that you might have been traditionally. And again, that's one of the benefits of being vertically integrated. because it only costs me what it costs me to make the bits and then repair the aircraft, not margin upon margin upon margin of a supply chain with certain price point expectations.
Next one is a curious and fun question. Jason, be ready for this one. Might you sell out to, well, not only sell out, but actually sell out to Airbus? That's a question. It's on the chat.
No, absolutely not. My dream since I was a boy was to build this business. All I've ever wanted to do was to make helicopters. When I'm not at work, I surf helicopter listings on the internet or go flying. You know, without helicopters, I would have nothing to do. So, and I'm not a terribly materialistic person either. So, you know, I had a nice life before I started this. So for me, this is what I consider to be my life's work. And there's plenty more products in me yet after HX50. So for me, I'd like to really pursue this GA 2.0 agenda and try and revitalize this whole bottom end of the industry. So no, I'm sadly not going anywhere.
So there you go. For all the ones that are thinking of putting a bid for Hill helicopters, forget about it. That's not going to happen. Hill is going to stay here for the lug run. It's answered. Done.
There you go. Brian is asking a question, very clever approach on the one-piece molding the foam inserts rather than machining them. May I ask what type of brand of foam you'll be using for the production aircraft, and also what is the density? It's a very technical question.
That is still an optimization parameter at the moment, because it changes a little bit with the molded foams. So at the moment, we've got a very, very productive working arrangement with Rubix, which are a UK foam manufacturing company, and they produce a range of products for various things that we do. So yeah, I can wholeheartedly recommend them. They're a great company.
Okay.
Okay, next one is easy. I can answer that one. Can we pay with Bitcoin? Yes, you can. A couple of clients have paid already. We have a gateway to receive deposits and further payments through Bitcoin and other cryptocurrencies. And the question next is, will the software be certified for DO 178/C?
Yes.
That's nice and, nice and quick.
So let me qualify. Let me just qualify that actually. All the critical flight software will be. So your primary flight displays, your FADEC, flight control computers, all of that stuff is fully certified.
Okay. Chad is asking a question. We're starting to see a few more folks with their slots up for sale, so their pre-orders up for sale. Are there any plans for a market board for this activity, or is the company inclined to discourage this?
In all honesty, I haven't thought about it. I'm very preoccupied at the moment. I think we always encouraged people that wanted to prospect to prospect, and so I think we've had a couple come up for sale where people's circumstances in life have changed dramatically, and for that we wholeheartedly support, and we've helped a little bit with some people over the years, and with other people we see the first of the people that bought slots being ready to harvest, and that's great. We all win together. So I haven't considered it. I'll give it some thought and consider whether that's something that we want to do. We don't necessarily want to compete with ourselves, but at the same time we want our customers that have prospected to be successful. So I'm quite happy for people to keep using the app to spread the word amongst our community. And for a long time there's been machines up on AvBuyer and Controller and things like that. So yeah, there's lots of ways that people can move these on.
Mm-hmm. And to qualify that statement as well, there actually has been very few that have come back up for sale. So very, very few actually. So, go ahead, Ruben.
Okay, have you put any consideration in getting some seed investment? We have already talked about this, but what about seed investment apart from helicopter sales, so on top of helicopter sales?
No, not really. I put the initial seed investment in, and then we had some UK grants.
Seed has sprouted.
Then we built an organic business.
Seed has sprouted.
So,
yes.
Yeah, that's it. The seed is an oak tree now. So
Yes.
no, we're okay. I mean, we're actively looking at some conventional forms of business finance for the scale up, but all the usual avenues that you would expect are open to us. So it's not a difficult prospect, and I'm really not minded to give it away at the moment.
That's good. Matthew is asking a question about, I can imagine there would be a number of pilots that would be interested in purchasing the HX50 by performing a syndicate in their region. Could Hill hold a database of interested people by country so that we'd be able to connect with other like-minded owners in the region that we're in? So is that something that has been considered?
It's something that's been considered in so much as how I answered earlier. It's something that is on the long-term plan. We would like to facilitate that. I'm not sure we've got the headspace for it right at the moment, but let me take that offline, and we'll have a think about it and see if there's something we can do. It's something we're keen to support. We just need to decide if now's the right time to do it.
Okay. Next question is, do you have any agents in South Africa? And I can address this one more from the sales perspective. No, we don't have any agents or distributors or resellers in South Africa, like we don't have in any other country. So Hill Helicopters has a unique model of approaching the market, and it is through direct sales. This has to do also with the fact that the education and the information needs to come directly from the source. It's much better this way. As you have seen, we like to be very transparent and clear. We find that it's better to come directly from the source always. We do have some novel plans that is going to be coming out soon, probably, and not exactly as agents, but we're going to have more presence in different parts of the world. That is what we can tell right now.
Excellent. And Dave is asking, yeah, I can go over this one as well. So Dave is asking, if I order, do you have any payment schedule on your website? I can't find it. So it's something that we don't put on the website. We do daily presentations where people can come, be informed about the aircraft, and then we present the current offer, because it does change on a regular basis. So if somebody wanted to order the aircraft today, like Ruben said earlier, they could do so with a £30,000 deposit, and that would lock in their price at £497,000. So still getting a discount of £98,000 at this point. And then the payment schedule is, the deposit is due when they order the aircraft, and then 1 year prior to their specific build date, the half of the remaining balance would be due, and then 3 months prior to their specific build date, the other half of the remaining balance is due. So that's what the current terms are for purchase right now. And if somebody's interested in purchasing the aircraft, they can discuss that with us and go through one of the presentations that we offer as well. Okay.
All right. Next one is a curiosity question. I'm just going to go over very quickly. Can you tell me what was the cost of going around the world that you guys did? So this depends how you structure it very quickly. We had some sponsors of people that were interested to sponsor, but you have to budget probably anything between 100 and 200,000 minimum to do around the world trip in helicopter. That's a ballpark that I can share there. You can go next one, Mischa.
Good. Yeah, next question is from Sean, and it says, do you have an estimate of amount of time for type ratings and the build school? Just need this information from trip planning when the time comes.
Yeah, the build school's a 2-week program. And that covers everything that you need to do with the safety course, everything that you need to do with the build itself. And then with the type rating, I'd allow a week for that. For very early aircraft, it's likely that we'll be starting type ratings before the build school, just to ease us into production.
Next one is a fun, simple question. What is the color you have chosen, Jason, to be the color of the first flying prototype?
I haven't decided yet. What the single most frustrating thing in this whole project is that I like black cars and black helicopters and things like that, and because we have this distinctive window line that relies on the silhouette in black, it doesn't look right in black. So I'm at a loss at the moment. I haven't decided what color we're going to paint it, and that's something I've got to solve quite quickly. So I don't know yet. I honestly don't know. I'll get it to work, and then I'll worry about the color.
We should make a poll. You know what? We probably should make a poll between our clients, and the clients decide it. You know, what's the most the color you guys want to see in the first prototype? We're gonna ask that.
That'd be fun. Yeah, we should do that. That'd be a fun poll. Jason would still have to have the ability to make the final decision, I think. But that'd be fun.
He doesn't like that.
He might be a hot pink if Yvonne has anything to say about it. But,
Yeah.
let's go with Noel's question. Can I have an update on the schedule for deliveries, please?
Yeah,
Anything changed on that?
nothing has changed on that. We're still shooting at all the same dates.
Okay.
I've shared that before. Clive is asking, Jason, what is the cost of the 4-axis?
25K sterling.
Yeah. And just, we have a configurator on the website, so any options that you guys are interested in, all the prices and everything for those are listed on the website as well. So next question is, how will the autopilot handle in high turbulence during flight?
Very well is the simple answer to that. There's a lot of work going on, or there's a lot of work about to go on with the latest version of the dynamics model, the latest version of the rotor system, to tune that to the best we can. We'll get it into the best condition that we can based on the simulations, and then tune it live on the prototype aircraft. But fundamentally, we have a high inertia main rotor system with a relatively low flapping hinge offset. So we've got a nice docile main rotor system. We've got a very streamlined fuselage, nice big stabilizer fins. So I think it's going to be about as good as you can get for a light helicopter. It is still going to feel like a light helicopter. It's only 1650 kilos, but it'll be a lot more planted than what most people fly. So I think it will pleasantly surprise you.
Right. Tariq is asking, will the prices continue to go up? If so, by what proportion over the coming weeks, months, and years? Can you talk a little bit, Jason, probably of the price strategy do you have in mind?
So the whole point of this business is that we're trying to make general aviation accessible again. So I don't have an ambition to push the price of HX50 up massively. It will always adjust for inflation, and based on market conditions, we reserve the right to adjust it over a period of time. But I always wanted the aircraft to be financeable for the same sort of monthly payments that you would need to make if you were to buy a supercar or an upmarket car, because that's what gives me the biggest addressable market. So for the time being, yes, there is some headroom, but the real boundaries for us, at what point does the thing start to not make sense for the biggest addressable market? Because I'm more interested in getting the aircraft out there into more people's hands and having a healthy general aviation industry again, than I am trying to drive the price up and sort of do less for more. So that's the strategy there.
Okay, excellent. Next question is from Barry, but before that, I just want to read out Derek's comment as well, just because it's a nice comment for you. It says, hello, Dr. Hill and team. Just wanted to give you a massive congratulations to you and the team. I've been following since Mischa's announcement of the project, and the progress towards your dream is very commendable. So that's nice from Derek. And
Thank
Barry
you,
is
Derek.
asking, how long will, after the HX50 is delivered, do you anticipate for the HC50 deliveries to start? And how will you slot the Cs into the production schedule of the Xs?
The Cs will be an extension of the production capacity. So the factory is built with that in mind, with growth potential in mind. And I think as it stands at the moment, the production for C is due to start in the summer of 26.
Good.
Jonathan is asking, is there anything in the HX50 that is suitable for using artificial intelligence driven interactive designs, such as support brackets and other like that? I think he's asking two things. One is AI, and then supports and brackets. I think they're not related to AI.
Okay, so in terms of AI, I'm really not an expert in the field. So I'm I'd need to go and have a look at it myself. The applications that have been offered to us thus far are primarily around vision-based systems for hazard detection and awareness. But the stuff that we've been shown to date is good in areas and less good in other areas. So there's still a big problem with spotting wires, for example, whereas other things are better. So it's an area that we'll continue to watch. I'm sure there are lots of applications, but it's not something that we're actively developing at the moment. We've got enough on our plate for now.
Okay. Brandon is asking the question, how will the aircraft be maintained, especially in foreign countries? So maybe just a little bit about the maintenance schedule?
Yeah, so the maintenance approach that we're taking is that every aircraft is sold with a maintenance course. So you can send a local mechanic that you've used for years and trust with your existing aircraft, or somebody that's recommended to you, to our factory. We will train them and type rate them on the aircraft, and then they have access to our tech support people at the factory. So it's distributed support all over the world with a direct line back to us. And then in terms of parts and access to technical publications, again, the single point of contact is the app, whether that's web-based or through your mobile devices.
Okay, Nathan is asking 2 questions. And the first one is actually an interesting one. We haven't heard this before, which is if a customer requests to customize any option during production. So we know that there is that decision to be made 1 year before customization. Is there like a last minute possibility of change? What are your plans there on the production? Can you clarify that, Jason? That's probably a good thing to clarify at this stage. Then also answer something about green model, which is what is your green approach envisioned for the future?
Okay, so 2 good questions. In terms of the first one, the latest you can specify your options is 3 months before build, and the reason for that is to allow us to make the parts in time to put your helicopter together. So for all of the major things, then your build would be locked in at that point. I think it might be possible to change some things fairly late in the day, but fundamentally there is an enormously complicated manufacturing system that goes behind putting these aircraft together. So I think you have to work on the assumption that once it's locked in at 3 months, the wheels are in motion. It's very difficult to change anything practically after that without making a big mess of my supply chain and all the things that go on in the background. So yeah, there's some practical limitations to what's feasible there. In terms of our green strategy, then we're taking a very pragmatic approach to delivering sort of carbon neutrality and net zero in the short term. My publicly held view is that we're a long way away from having any kind of batteries that would work for a helicopter with reasonable performance. I've done some work with hydrogen and helicopters and fuel cells in the past, and the huge hydrogen fuel tanks become very impractical very quickly, and so I don't think any of those are realistic options in the short term. Our approach is we're currently exploring with a biofuel company that has a novel technology. We're going through due diligence with them at the moment. This company has a novel technology for making 100% carbon neutral biofuel that can be synthesized into a direct replacement for Jet A. And so our gas turbine has been designed to run on bio-based fuels so that we can get down to carbon neutrality. Within the manufacturing process, we do everything that every business is being asked to do at the moment in terms of management of energy and recycling and whole life cycle plans for the aircraft to be a responsible manufacturer. But the biggest thing, of course, is what we do about fuel. And I think for the next 20 to 25 years, aviation will require synthetic liquid fuels. And how they're arrived at, whether for general aviation, I think we genuinely can do biofuels. I think it's such a small market that it doesn't compete with food crops. It doesn't need too much space if if you use the right technology. Obviously, for main commercial air transport, that's not quite so easy. But there are a number of very promising technologies, and synthetic fuels is the route that we're taking because it is deliverable. It's deliverable today, and the aircraft still makes sense. It's no good pretending that electricity can be magicked from the ether to fund all sorts of wonderful configurations. It just won't work like that. And it's difficult enough to justify buying a private aircraft or to justify operating a light aircraft without then knobbling the performance to a point that it just makes no sense at all. So we're being pragmatic both technically and commercially to give the best environmental outcomes right now.
Perfect. Great answer there. So Gary is asking, should an auto rotation be required? Will the wheeled version have an auto gear down system?
Not auto gear down, because you might want to keep the gear up because it'll give you much better range, but it will certainly alert you to the fact that it's time to put the gear down when you get within a certain distance of the ground. So there's some intelligence built into the system, but the pilot is responsible for flying the helicopter.
Okay. Keith is asking, during the build school, do you still plan to use in-house video so we can take our own build experience back home, a film that we can share with others, families and friends?
Every detail of it will be documented. So yeah, you'll have lots of opportunities for us to capture video that you can have yourself, to have a full build log of everything that you did and learnt, and there'll also be some materials of the aspects that you're not required to build, but are there for you to learn from, so that you can take that with you and refresh your memory about how the aircraft systems work and why we do the things we do.
Excellent. We're just getting down to the last few minutes here. We've got about 6 minutes to go, and so we're going to try and fit as many questions as we can into that time. Fred is asking, can Hill Helicopters log into the helicopter system wherever it is in the world if there is a problem? Can a remote control and update also be performed?
The aircraft does send data back to us about its health and its usage, and there'll be a big update on this a little closer to the time, because it will be part of our offering for insurance and active safety management and active health management of the aircraft. So yes, the system is able to send data back to us. Obviously there's all sorts of data management laws that we have to comply with to do that, but fundamentally it's designed to be smart, it's designed to protect the aircraft, and it's designed to protect the pilot and the occupants.
Charlie McCann is asking, have you applied for and received all possible local and UK government grants you're able to get? Everything possible. Have you tried to get those?
The simple answer to that is yes. The grant scene is hugely complicated. There's millions of little pots of money that are often more hassle than they're worth. We've applied for some major pots of money from the ATI, which is the Aerospace Technology Institute in the UK, and never quite managed to make a project make sense to them. They have very particular themes. For a long time, they spent ages funding batteries because that was going to be the future. And at the moment, the flavour of the month is hydrogen because that's going to be the future. And when they realise that that doesn't work, I guess they'll fund something else. But yeah, where we are and where they are doesn't quite align at the moment. But that's the only real funding source in the UK for us at the moment.
Great. And Terry's asking, when will you be able to share the blade dampening solutions?
Fairly soon. There's nothing clever about those. That's a very conventional approach. That's not the bit that's clever. It's packaged very nicely, as you'd expect, but that'll come out fairly soon.
Okay.
Joseph
I'll give you a hint. I'll give you a hint. It's a torsional elastomeric damper is how we do it.
Okay.
All right. Joseph is asking about air trade shows, specifically Dubai Air Show in November 2023. Are you going to be present? I can answer that. We have decided we're going to be entering the trade show space when the full prototype is ready. So we prefer to do that way. It's a strategic decision, and I think that everybody's going to want to be in a trade show to see the helicopter there. And Hill is actually going to be an attractive point. So that's a decision we made. And once the aircraft is ready, which is going to be this year, then we're going to be going to all the possible trade shows that make sense.
Mm-hmm. And Bachman is asking a question. Just before I ask the question, this is a bit of a milestone moment as well. We have HAI starting today, so I think a lot of people's attentions are focused on that. But even despite that, we've had just about 2,500 people connecting onto this this AMA today. So really neat to see the support that continues to grow
A record.
every month. Bachman is asking, was that?
A record of connections today.
Yes.
A record.
It is a record, absolutely.
Yeah, thank you to everybody for your continued support. It does mean the world to all of us and the extended team here. Thank you.
Mm-hmm. Excellent. Bachman is asking, I have seen the changes of the AW09 concerning the fenestron. What is your approach to get a powerful tail rotor authority, or would a normal tail rotor be better, as a big tail rotor or a big tail is a problem in the mountainous winds conditions?
So it depends what you want your helicopter to be. So if you want your helicopter to be flown by professional pilots, and you want it to be a utility-based machine, and you want it to have performance above all else, then an open tail rotor is a nice solution. But they're very noisy, and they're very susceptible to damage both in flight and in particular around the ground. When you're designing an aircraft that's main duty is flying from hotel lawn to hotel lawn in a straight line as fast as you can, having great power reserves, and being quiet and a responsible neighbour, then a ducted tail rotor, which is what we use, is a better solution. From a power point of view, there isn't a lot in it if you design it properly. And the big fin, yes, it can be challenging in gusty wind conditions. We have enough tail rotor authority to be able to overcome gusts. If you have the 4-axis autopilot, you have a yaw damper that will be far faster on the feet than you can be. And so those issues are managed, but you get all the benefits of reduction of drag in forward flight, very quiet operation in and around, well, in all flight conditions, and of course the ability to fly even at relatively low speeds in the event of a total tail rotor failure, which is much more challenging with an open tail rotor where the vertical fin is in some way limited by not blocking the tail rotor too much. So my view, as you can probably expect, is that a ducted fan is the best choice for this size of helicopter.
Fantastic. And that just leaves us for the last very quick question. This will be the last one. We're right down the hour right now. And what lightning strikes prevention have you planned for the HX50? That will be the last one. Then you can close it, Jason. And it has been a phenomenal, again, a Q&A session with 1 hour and 2 hours total presentation, and an actual presentation and Q&A 2 hours. So here we can close it once more. So go ahead, Mischa, Jason, with the last one.
Yeah. And I just want to say before you answer as well, thank you to everybody that joined in today. It was great to have you guys all back. The questions were wonderful. It was good to have all of them. And Jason, thanks for taking the time out of your very, very busy schedule again to update everybody on what the latest build status is. So go ahead.
Thank you. So those of you that have been following us for a while will recall that we developed a lightning strike protection system based on a copper mesh that is built into the laminate. So in all the crucial zones where you're likely to have lightning strikes, there is a copper mesh that's built into the laminate that provides the conducting pathways through the carbon without creating massive structural damage. The rest of the structure is then suitably electrically bonded so that we can conduct the lightning through the structure to a detachment point, as you would get with a metal aircraft. So very, very conventional stuff, and then obviously all of the EMC and HERF protection on top of that as well. So that's a particular area of expertise of Martin, who's got a lot of experience in much bigger helicopters. So with that, I'd like to thank everybody for their attention, thank everybody for their questions, and thank everybody for their continued support of the project from around the world. Thank you very much, guys.